Okay, welcome to Math 25A. I am your instructor, Chris Copeland. The first lesson that we're going to do here is 2.2, Finding Limits Graphically and Numerically. Okay, so if we look at this first problem here, so example 1, estimate a limit numerically. Evaluate the function f of x equals x divided by the square root of x plus 1 minus 1 at several x values near 0 using the results to estimate the limit. Okay, so this right here, which if you've never taken a calculus class before, this probably looks not familiar to you. This says the limit of this function as x approaches 0. This is different, okay? This is different than f of 0. F of 0 would be simply just plugging 0 into this function and evaluating this function. I think you can see here if we plugged 0 into this function, the answer here would be undefined. But we can use this idea of limits to see what this function approaches instead. And how we're going to do that, we're going to pick x values coming from the left that get closer and closer to 0 but never get quite to 0. Okay, so, and you want to pick numbers that are relatively close to 0. So I'm going to start by plugging in negative 0.01 for x into the function. Okay, and if I did that using a calculator, so if I did f of negative 0.01, that's going to end up being 1.995. If I plug in negative 0.001, I'm going to get 1.9995. If I plug in negative 0.0001, I'm going to get 1.9999. And I think you can see here that I can continue to pick x values that are closer and closer to 0 but not quite 0 coming from the left, and it's going to just getting closer and closer and closer to 2. Same thing coming from the right. So now I'm going to pick x values coming from this way that are getting closer and closer to 0. So I'm going to start with f of 0.01. And when I put that into the calculator, right, plug it into this function here, I'm going to get 2.005. Then I'm going to plug in 0.001, and I'm going to get 2.0005. Then I'll plug in 0.0001 into the calculator, and it gives me 2, but that's actually inaccurate. It's just, it's so close to 2, it's rounding up to 2, but it's really 1.9999999 going on for a really long time. Okay, so from this approach, we can determine, since coming from the left, okay, when I pick x values coming from the left, it approaches 2, and when I picked x values coming from the right, approaching 0, both end up equaling 2. So therefore, we can say this limit is equal to 2. Okay, so notice the difference here. the limit of this function is equal to 2 when x is approaching 0. But f of 0, if we didn't use the limit notation, it would be undefined. Okay? All right.